Hi, welcome to Text Recognition. In this section, we're going to discuss implementing text recognition on the device, implementing text recognition on the cloud, and trying out text recognition. Implementing text recognition on the device. In this video, we're going to discuss working with Firebase VisionText detector, detecting the camera feed image, and finally displaying the results on the screen. In Android Studio, if we open up our live preview activity, we discussed previously that when we want to switch the models, we basically need to feed in a different frame processor into the camera source, like this for example. So since now we're talking about text detection, we're going to look at this class here, text recognition processor. Now if we click into here, the first thing we'll notice about text recognition processor is it overrides a lot of methods. So we'll see that it extends Vision Processor Base, and its generic type is Firebase VisionText, which we'll get to a little bit later. But let's look at Vision Processor Base. We'll notice that, as expected, it takes a generic type and that it implements Vision Image Processor. So Vision Image Processor, as we can see, is simply an interface. It has three methods overloaded called process and one called stop. The first thing we'll notice about these process methods is that they all take a graphic overlay as the last parameter, right? Here, here, and here. And the other difference is that this one takes a byte buffer and a frame metadata. This one takes a bitmap, and this one takes an image object and a rotation. Now these two are basically used to process still images, and this one is used to process a live camera feed. And this is the one we're going to discuss in this course. Now if we go back to Vision Processor Base, we're actually going to take another step back and then come back into this. So we'll go back to text recognition processor, and we'll look at some of the methods that are being overridden here. We'll notice on failure and on succeed, which these are used, as we'll see, when the image reads text and then spits back the data. This is where it'll be. And then detect an image and stop. And of course we have our constructor. So in our constructor, we'll notice that we are instantiating Firebase VisionText detector. Now Firebase VisionText detector is actually the class that does all the work. As you can see here, this is a private class in the sense that it is not open sourced. So we can see here that there's a bunch of different variable names, var1, zz, gw, etc., etc. We're not meant to know what goes on in here. And we'll see how detector gets the job done. So we'll look at detector here where it's used. Stop, this is pretty straightforward. We don't really need to discuss this. The two important methods here are detect an image and on success. So let's look at detect an image. So detect an image is a method that's overridden, and its return type is a task of generic type Firebase VisionText, and the input parameter is a Firebase Vision image. Okay, so let's look at what this overrides. So this is an abstract class in Vision Processor Base, which again, text recognition processor extends Vision Processor Base. Let's look at Vision Processor Base. And the method we want to look at is this abstract method, detect an image. So let's just do a search and see where this is used. So we'll see that there's three matches. It's used in detect in vision image, and it's there in a comment, and then there's the abstract signature. Okay, so here's where it's used. Let's just clean this up a bit here so we can see what's going on. Okay, so this method, detect in vision image, takes a Firebase Vision image, a frame metadata, and a graphic overlay. Now basically it invokes detect in image with the image parameter, and then it adds an on success listener and an on failure listener. And as you can imagine, basically what this does is it'll invoke on success that is implemented here. And on failure, it'll invoke what's implemented here. Okay, so that's pretty straightforward. Now looking at detect Envision image, let's again do a search for this and see where it's used. So here we have 4 matches. There's the method signature here, and then we'll see that it's used in each of the process methods. So there's the first one with the camera feed, byte buffer, and frame metadata. And then there's the one with the bitmap, and of course the one with the image right here. So let's look at the one with the camera feed data, byte buffer, and the frame metadata. What does this method do? So this method, we'll see here, it creates a Firebase Vision Image Metadata object, which is basically like a settings object. We can ignore that for now. We can just leave it as it is, and we can use it as it is in our own app. And then basically it invokes detect Envision image. Now this process, if we go back to text recognition, we'll see that detect an image. Now we'll see here that this method process, if we right click on it and we go to find usages, and we say yes, we want to find usages of the base method, we'll see here that if we go to our camera source app, it processes it in the run method. So basically while the camera feed is running, we want to process the camera feed with the data of the camera, and our frame metadata is just some of the camera information, and then the graphic overlay that we defined in the live preview activity. So we'll see what it does here is it passes all of that information into detect Envision image, which again invokes detect in image, which is abstract, which we implemented here. So it's our detector.detect in image. So basically we're telling it, take the image from the camera feed and feed it into this Firebase VisionText detector. And as we can imagine, this Firebase VisionText detector, which again is not open source, it searches based on a local set of strings for any text that's in the camera feed. And then the results going through here, through this process, it'll return through this process here, and with the onSuccess listener, it'll give us back our information over here in onSuccess. Now, let's look at Firebase VisionText. And keep in mind, Firebase VisionText, this is the class that's used with Firebase VisionText detector in order to return the text. So in your own code, you don't need to use text recognition processor. You can implement your own code structure, but you will need to use Firebase VisionText detector and Firebase VisionText. Now, in the onSuccess method, we'll see that it returns Firebase VisionText. The other stuff we can ignore for now. Our goal is to get the text out. We want some strings. So looking at Firebase VisionText, we'll see 3 for loops here within each other. The first thing we're doing is we're getting the blocks from the results. Okay, so if we open up Firebase VisionText, we'll see that there are 3 main building blocks here. There's block, and each block contains, if we click into it, we'll see that it contains a list of lines, and each line contains a list of elements. And each element, you can't see it here, but it has a bunch of strings and some other stuff. So if we go back to our for loops here, we'll see that if we can get the blocks and we can iterate through them, we can get a list of lines. And if we iterate through them, we can get a list of elements. And if we iterate through the elements, we can get a list of the strings that we retrieved. So here, this is basically taking it and putting it onto the screen. But if you just want to get the string, what we can do is we can say string s equals elements.get k.getText. And there you have it. We have the string. We have obviously a list because of all the loops. So we'll have an array or a list or what have you of strings that were discovered on the screen. And this graphic overlay, as we mentioned, it's just taking the text and drawing it into a rect and then onto the canvas, and it's just displaying it onto the screen. Pretty straightforward stuff. It's not stuff that is really important for this specific video. So now that we know that detect Envision image basically processes everything and does all that through detect in image, and all of our results are in on success, we can make some modifications here if we want to. So we can do something like, here we can get the text and we can put it into a log, or we can display the text in a different way, for example. We can do whatever we want in here and it's nice and clean. And that's basically how text recognition on the device works.